Hi, friends. Once again, in continuation with our efforts to understand welding better, uh, a different kind of a welding application which we use it, which you can see on your screen, is buttering or overlay or hard facing or reclamation or built up. That means we are going to use the welding process or processes to deposit material such that it will give some unique properties or it will help in building up the lost thickness, wear out thickness, or for any other physical or metallurgical means. So, what are those overlays or the buttering? It is typically being done either on the edges or on the surface, but when it comes to putting it for a corrosion resistance, the internal surface of that entire reactor where the corrosive chemicals are going to get reacted, I think that gets onto every portion of the internal part of the. So that means we are going to have it on the ID of the nozzles and the entire shell, dish stand, and any other surface which is going to come in contact with the corrosive liquid. So that's the way we will be looking at it. And this is, as I said, for building up a thickness which is good to take care of the service life. It may be 1.6 millimeter, 3 millimeter, 5 millimeter, depending upon the service and how aggressive is our corrosion. Sometimes it is used for hardness, that is for hard facing. So you want, like in earth moving equipments, you want a very hard surface which is going to dig into the mud or soil or going to lift heavy stones, or it can be a part of a crusher, or it can be a part of a shaft where you are going to have the bearing surfaces. So all such areas you require a very high hardness, crossing sometimes even 60 HRC also, or there could be any specific property you are looking for. Maybe on a hard surface you are looking for a soft surface, or you are looking for creep resistance in this. So it all depends upon the application. You have to choose the consumables. And the third application is like a lamellar tear, as you see here in this particular sketch. This layer which is given here is to prevent the lamellar tear, which is happens because when you have very thick rolled plates in the Z direction, the sufficient grain orientation doesn't get, the compaction of the grains doesn't happen in the Z direction, and that's where we get a lower strength. So you dig away or take away some material from the parent metal which has Z directional low properties and deposit weld metal like shown here. So it is called as a buttering or a layer to prevent the Z direction. It's kind of a built up, but that's deliberately you remove material and built it up so that the weld is able to take in the Z direction the stresses which are going to come after you weld this vertical member or a beam. And when we are welding and doing buttering, that time there is no stress because it's kind of a bidon plate, so you don't land up into it. Now what we are going to see in the next slides is, like any other welding, what are all the care and precautions we need to take while depositing either the complete buttering on one side or on one of the plates, which is maybe a mild steel plate and the other side is stainless steel, and you want to join it. So you butter it with 309 stainless steel grade and then weld it together with 308. So either you can do that, or you have buttering or hard facing, so you deposit layers and passes to match up as shown here. So this is how we have to really look into it. So let's go and see the details of welding now. Okay, so a normal weld bead which we deposit is looks like this. So what are all the important parameters which we do it for butt welding also, but they become little more important when we are going to do a overlay, where we are going to do side by side lot of layers, and even a fine porosity, crack or inclusion in the surface of this weld will get attacked with the corrosive liquid. So the two important parameters here is the overall thickness of the weld deposited, as the one which you see it on top of the plate, and there is something which is below the plate, and even beyond that there is a heat affected zone, as we get in any our other welding. So you have basic welding deposition here, that is the primary surface, but there is a diluted layer, and beyond diluted layer, depending upon the temperature the parent metal or the base metal is going to see, you are going to get different structures, and some of them are hard. So those are the ones which are really worrisome for our heat affected zone, and others can have slightly stress relieving, so a lower in strength also sometimes you get. And this is a beautiful picture which gives how the dendrites and the solidification is going to happen with the number of passes, and each pass, so you observe here that we have the penetration side, the heat affected zone, but important is that you see here even the angle is also mentioned. So we should have very narrow depth of penetration as seen here, this particular one, and as wide as possible. It should not be sharp. In our next slide I will show you how a typical butt joint weld penetration, if you cross section, it will look like. So we try to give as flat as possible, as low in the depth, and that's the technique which is different from the normal butt joint or a fillet joint, and that's where there are special slides which have been prepared here. So the configuration of this profile, the weld profile, is very important, and that is where this angle comes into a play, because our second run is going to, the pass is going to be either on this side or on this side, which we will see it in the next slide, and that must get properly fused with this entire line here, as you can see here the overlap which has been given here. And the weld bead with the penetration pattern, if it is so deep, then the dilutions are going to be very high, because this is what is going to be the diluted material, and we want the bare minimum dilution from the parent metal to come. So we may use little higher arc length for overlay, which we don't use it in our butt joints, because there we are concentrating more on penetration. Here our focus is a very shallow penetration, wide bead, and a beautiful angle. I mean, the angle as it is shown here should not exceed 60 degrees. I mean, ideally it should be between 45 to 60. Very smooth profile it should have, but if it goes beyond 60, it becomes too sharp for the subsequent run to get properly deposited. As you see here in this slide now, the number of layers, the overlap has been shown as a half of the base metal overlap, which in turn comes to about 30% on this where it goes, and then the rest everything is going to see it. But another important parameter which I want to show here is, see this red and yellow portions, they are our penetration side, and the penetration should be as uniform as possible, as shown here. Still there are few areas like this P here, which is larger, here it is lesser, and this is something which will give us trouble in our bend test. So a very uniform, as you see on the top of the surface, we should be able to see it at the bottom of the surface also, and not creating any anchoring which can lead to failure in our bend test. So the top also shall be as uniform as possible, as flat as possible, so that the subsequent layers we can once again deposit with 10 to 12%, 15% penetration. But if this kind of anchoring is going to happen in the subsequent layers also on top of this, then the dilution levels will be higher, and a clean chemistry which is required for corrosion resistance or for hardness, you may have to deposit one extra layer which is going to be expensive. So we have to take care in the first layer itself, like a root run, that we don't give much of a dilution but have a very good bond strength of that is required to be really achieved, and at the same time we don't miss out on our other parameters. There are variations in the slide which is shown here, and that is something which is not acceptable. A large variation should be as uniform as possible. Now these are the typical weld geometries what we are seeing it now. So if that angle is not maintained, as I said, then you will have something like this, very sharp. See, these are all which are not acceptable. Only the smooth ones which are having a good contour will be good. And if you get that, then your barrier layer, the first layer and the second layer will also have a very good uniformity. Finally, the joint should look like this. That means you are going to have first a butt joint, below it with number of layers and passes, narrow or regular, conventional, and on top of it, to have a good corrosion resistance, you are going to build it up, this additional material on top of the weld. So unless this weld is sound, your overlay will not be sound, and positioning layers and passes in this buttering or overlay also becomes very, very critical and important for us to really do it. So that's the importance which we give for the overlay. See how beautifully they have done it here on the OD. On the ID also we can achieve a similar kind of a thing. Even small diameter tubes, there are mechanisms which are developed where we are able to do with the TIG welding, and 1.2 millimeter wire deposition on the internal pipe for developing a nozzle or for a passage of corrosive liquid on top of from inside it, and that's the way we'll have to really worry about it and look into it. So I hope that you are enjoying this type of welding also, and understanding the features which are required to be done. So I will repeat again that the angle, the depth, now this kind of a penetration is not acceptable in overlay. We must get the flat as I showed you in the earlier slide. Width should be as maximum we can get it using diameter into maximum 2 times, or if it is make submerged arc, depending upon the voltage arc length we are choosing, it can come to that extent. And this is the way we should start developing our welding techniques. So thank you for listening to this video on overlay, buttering, hard facing, and different entities which are required to be done and achieved. So what we actually get is a dye penetration test to see that there are no surface defects allowed, because any surface defect means crevice corrosion is going to increase. Hard facing will have a crack initiating from there, built up. If it is there, it is not going to be a sound metal for us to have a built up. If it is for lamellar tear, then that could be a potential point acting as a notch. So a lot of care is required when we are going to do this build up. We can also do ultrasound to see the bond fusion, because DP will give you only the surface defects. Ultrasound will give you if there is a good bonding. if there are any side wall fusion issues, if there is any penetration issues in number of layers which we are going to do it. So every layer has to be thoroughly cleaned. If you have any doubt, grind it to white. Don't see any undercuts, and then do a DP, and then once the DP is properly cleared, washed, then you can deposit weld material on top of it. So not only welding, while taking NDT also you have to be very careful. Post NDT, clean it before you start the subsequent layers. The cleaning has to be as thorough as possible, and wherever you have doubt, grind it, so that only wire brushing or acetone cleaning should not be trusted and believed. Thank you so much.